Welcome to the presentation on finding the longest substring with distinct characters. Today we will be discussing an efficient approach to solving this problem and walking through an example. Let's dive in. Here's the problem statement. Given a string S, we need to find the length of the longest substring that contains all distinct characters. In other words, we need to identify the longest part of the string where no characters repeat. Let's look at some examples to better understand the problem. In example 1, we have the strings gigs for gigs. The longest substring with distinct characters is EKSFORG with a length of 7. In example 2, we have the string AAA. Here the longest substring with distinct character is just A, so the length is 1. Finally, in example 3, the string is ABCDEF ABCBB. The longest substring with all distinct characters is ABCDEF, which has a length of 7. The goal of the problem is simple. We want to find the length of the longest substring that contains no repeating characters. This helps us reduce redundancy and work efficiently with the string. The problem has few constraints. The length of the string can be up to 30,000 characters and all characters are lowercase letters. So we need an efficient solution to handle strings of this size. One efficient approach to solving this problem is the sliding window technique. The idea is to use two pointers to represent the window's start and end, expanding and contracting the window as we move through the string. When we encounter a duplicate character, we shrink the window from the start until the duplicate is removed. This helps us maintain a substring with distinct characters at all times. Why use the sliding window technique? It's efficient. By using two pointers, we only need to process each character once, leading to a time complexity of big O of n, where n is the length of the string. To track distinct characters, we can use a hash set. This allows us to quickly check if a character is already present in the current window. If it is, we can shrink the window until the duplicate is removed. Let's break down the algorithm. First, initialize variables maxLength to track the longest substring length, start to represent the start of the window, and hash set to store the characters in the window. Next, iterate over the string. For each character at the end pointer, if it's already in the hash set, remove characters from the start pointer until the character is no longer a duplicate. Finally, update the maximum length of the substring. Let's walk through an example. In the string gigs for gigs, we start with the end pointer at 0. The character G is added to the hash set, and the window now contains G. As we continue, the end pointer moves to the next character. We expand the window and add characters to the hash set. We keep expanding until we encounter the first duplicate character E. We then shrink the window from the start to remove the duplicate. By continuing this process, we eventually find the longest substring EKSFORG with a length of 7. Let's look at another example. In the string AAA, the only substring with distinct characters is A, so the longest substring has a length of 1. The time complexity of this approach is big O of n, since each character is added and removed from the hash set at most once. The algorithm runs efficiently even for strings with 30,000 characters. Let's take a look at the code implementation. We start by including necessary libraries and defining the function longest substring with distinct chars that takes the string as input. In the function, we initialize the hash set, start pointer, and max length variable. We then iterate over the string, adding characters to the hash set and adjusting the window as needed. Finally, in the main function, we test the function on various strings such as gigs for gigs, AAA, and ABCDEF, ABCBB. The program outputs the length of the longest substring with distinct characters. In conclusion, we have learned how to efficiently find the longest substring with distinct characters using the sliding window technique and hash set. This approach has a time complexity of big O of n, making it suitable for large inputs. That's all for today's presentation. I hope you found the solution insightful. Do you have any questions or thought on this approach?